So here's a practice exam question for you. This is a dual operational amplifier circuit. So there's two op amps and we're asked to find the voltage out. So how do we do that? First off, we'll start at the first operational amplifier. And we know our ideal op amp rules. The ideal op amp rules are that the current going into both input terminals is 0 amps. Since the impedance at the inputs is super high, so no current can flow in. We also know that the ideal op amp makes the voltages at the input terminals the same. So if the non-inverting input's connected to ground, the inverting input is also 0 volts. On the second op amp, this one's connected to 10 volts. So the inverting input is also going to be 10 volts. To solve this question, we should first start with the first half and we'll solve for the output of the first operational amplifier. Then we can use that to solve for the output voltage. So I'm just going to call that V1 and then I want to do KCL analysis at the inverting input node. KCL tells us the sum of current out of a node is 0 amps. So on the inverting input node, there's two paths where current can flow. I1 plus I2 is 0. So what's I1? From Ohm's law, V equals IR. So current equals V over R. For current I1, the voltage across this resistor is 0 volts minus 12 volts. I2 is 0 volts minus V1 over 10k, and that's 0. We can rearrange this to find V1. So I take this and put it over this side of the equation, and that gives us this. And then if I multiply both sides by 10k, that cancels those out, and we're left with V1 is equal to negative 12 volts. Right, now we know that V1 is negative 12, we can now focus on the second op amp. So doing a KCL around the inverting input of the second op amp, sum of current leaving a node is equal to 0 amps, and there's another two paths where current can flow, I1 and I2. The current I1, 10 volts minus negative 12 divided by 10k, and the current I2 is 10 volts minus V out divided by 10k, and that's equal to 0 amps. So now we're only left with one unknown variable, and that's V out. So if we rearrange this equation, we can solve for V out. V out is 32 volts.